This is section 2.2, more on functions. Okay, so here is just a real world graph showing fluctuations in blood pressure throughout the day. We are going to be talking about increasing and decreasing intervals, and so this is a good real life example. We see the blood pressure increasing, and then we see it falling down and decreasing. When we are considering a function to be increasing, that means that we're talking about where our y is, right? So I'm looking at, oops, I'm not ready, the y, right? So I'm like, okay, is it traveling up? As I'm traveling from left to right, it's traveling upward, so that function would be considered, or that portion of the function at least, would be considered increasing. Okay, as I travel from left to right, my graph is going downward, right? So I would have, like, if we were talking about slope, increasing, decreasing, right? So I'd have like a negative slope. But that would be considered, that portion of the graph would be considered decreasing. And then if there's no change at all, so I'm staying at the same y value, then it would be considered constant. So usually where I see issues with students answering these questions is they want to answer in terms of y. And so we'll see how, even though we're looking at the y, like going up and down, how we answer the intervals in left to right. All right, here's another real world example. It's showing the correlation between the number of people in prison and jail and the price of cocaine and heroin. So we see that as the number of people in prison and jail increase, the price of cocaine and heroin decrease. So think about when people are doing studies, right? They see what the correlation is. Okay, here we're looking at measles cases in the U.S. from 1944 to 2007. Again, just seeing a real world example that shows a lot of increasing and decreasing here. And then we see a huge decrease in 1964, 65, when that vaccine is licensed. And then even though there are some increases towards the end, it's very constant. So just to recap, if I'm looking at this function right here, I would be increasing on this portion of the function, right? This would be the interval that I'd be increasing. And then this interval right here would be decreasing. This interval right here would be considered increasing. And this interval right here would be considered constant. So I always like to think of it like a roller coaster, like what part am I slowly starting to roll up that hill, right? And then what point am I screwing my head off because it's going downward and I'm decreasing, right? And then usually like at the end where it's constant, you're catching your breath. So I just think, okay, what part is going upward, downward, and then staying constant? So looking at this first question right here. It says, use the graph to determine A, the intervals on which the function is increasing, if any, the intervals on which the function is decreasing, if any, and the intervals on which the function is constant, if any. So let's take this into consideration. We said that increasing meant that when I traveled from left to right, my y value was increasing, right? So I would have to see something along the lines of this. This doesn't have to, it could be curved. It doesn't have to be a straight line, but something that's increasing. And I don't see that anywhere here, right? So that means that none of my intervals are increasing, okay? So what about decreasing intervals? So anything as I travel from left to right, where my graph starts to drop lower in my y values. And the reason that I'm specifying that we're considering y values is because I want you to be able to separate this from what we're looking at when it's decreasing to how we answer. So I see from here to here, my function is decreasing, right? When I go to answer though, the interval, I'm no longer looking up and down. I'm looking from left to right. So there was an arrow here, meaning that it's going to keep going on and on and on and on, or it came from negative infinity, right? So always answering in parentheses when we're answering about increasing and decreasing intervals on functions, starting from negative infinity all the way up until what? 1. Again, using parentheses. Okay, so now what about constant? What part of my function is constant? Well, I see this nice flat line, right? And that began, so again, looking from left to right on my y-axis, it began at 1, and this arrow tells me that it's going to keep going on and on into infinity. So usually where the confusion comes from, let me show you what not to do. Sometimes that's helpful. Oops, I meant to erase that. Okay, is that people will say, oh, okay, I see that it's decreasing from here to here. And they will then look at the y-axis and say, oh, it's from 2 down to -3. It stopped decreasing at -3. So that's how low it went, right? But when we're saying starting from where till when, we're looking here. We're answering in regards to the x-axis. So be careful for that. You're not, there are some questions that I will ask you, what is the minimum? What is the maximum? But right now we're just saying starting from here. And I also, in class, I usually explain to the students, okay, if I'm walking underneath a roller coaster and they say, well, how many feet into the ride does the roller coaster stay constant before it drops? Right? That I'm not going to say how high it is. I'm not going to say how low it's dropping. I'm going to be talking about how many feet just walking underneath it. So this part right here. Let's look at another one. Okay, so intervals on which the function is increasing, decreasing, or constant. Okay, so increasing, I see increasing right here before it starts to decrease, but I also see increasing right here. So remember, we're always answering in terms of the x-axis. So domain, right? What part of the domain is my graph increasing? Well, we know that this arrow will just keep going, 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 right? So all the way from negative infinity to, where is that in terms of x? On my x-axis, that is x equals 0. So from negative infinity to 0, but then I also see increasing from here to here. So also beginning at 1 until we reach 2. Sorry, that makes such a mess. But I think it's literally having your eyes see the graph moving up and down, but then having to say, hold on, but I'm answering in terms of my domain, so left and right. And these transition points right here are where we start going into a different direction. Either we go from, decreasing to constant or increasing to decreasing. Okay. All right. So B, where are my decreasing intervals? Well, from here to here. So that's from 0 to 1. And then starting at 2 all the way to infinity, right? Because even though I only see my graph there, that arrow tells me it's going to keep going and going and going. So 2 to infinity. And look, if you use all of those intervals, that would cover the entire domain, right? Negative infinity to 0, 0 to 1, 1 to 2, and 2 to infinity. There's nothing left out there. And C is asking for constant. Were there any parts of my function that were constant? No, there wasn't. So that would be none. All right, it tells us to use the graph to determine the following. Find the number at which f has a relative maximum. So that's going to be the highest point that we see on the graph. We see the ends of this graph have arrows, meaning that it's going to keep going up and up and up into infinity, but it's what part we see that has the relative maximum. So, and then what are these relative maxima? Okay, so we're regarding these transition points, highest transition points, lowest transition points. So they'll ask you, well, where is it? When they're asking you where it is, again, they're asking you in regards of the x-axis, so left to right. Well, here I'm at 0, right there. Right here I'm at 1, and here I'm at 2. Okay, so A, where is the maximum? Well, it's at 1, right? And then it says, well, what is it? So basically they're saying, okay, again, how far into the roller coaster ride is the highest point? And I'd say, oh, it's actually only 1 foot in, right? And they're like, oh, well, how high is it? Well, now we're going to look at the y-axis. Let me get a different color here. And I'm like, well, how high is that point? Well, it goes all the way up to 3. Okay. I'm going to erase everything so it's a little cleaner. So again, what is the numbers at which f has a relative minimum? Okay, well, here's my minimum, right? And there's actually 2 points there. So it's at 0 and 2. And then it says, okay, well, what is it? Well, how low did we go? We went down to -1. Again, regarding the y-axis now. So this can be very confusing. So practice, practice, practice. When you go through your homework, I would do these, and if it's still like, okay, I could not have done that without the question help, then I would do it again. Because the more you work through it, the better your eyes will be able to decipher what are you looking at. Okay, what's the highest point of this roller coaster? Okay, where did that occur? And then how high was that? So that's the way I separate it, but you might be like, okay, that makes no sense. And so you find your own sort of kind of real world example of it, or just silly way to remember it. Okay, so they want to know the domain of f. So remember, the domain is all the possible x's on this function. Okay, well, this is going to keep going. So all my possible x's would be -infinity to +infinity, because this right here would keep moving further and further to the right, and this is obviously coming from the left. So -infinity to +infinity. Then it says, okay, well, what about my range? So remember, when we talk about range, we're talking about all my possible y's. Well, I see that the lowest point is right here. So -1, and then this is going to keep going up and up, so it'd be +infinity. Now notice that I use the bracket here, right? Because I'm talking about domain and range, and in that -1, it's included, right? So because -1 is included, I use a bracket. Now, when I start talking about intervals of increasing and decreasing, no matter what, I'm going to use parentheses, because those transition points, we don't, consider, oh, is it included or not included? Okay. X-intercept, so any place that my graph intersects the x-axis, I have 2 and 4. Okay, y-intercepts right there at 8. Intervals on which f is increasing. Okay, and let me erase some so we can. So I see it increasing. Here's a transition point. And then again, that would keep going. So I'm just talking about from left to right. So on my x-axis, that would be 3 and then to infinity. Intervals on which my function is decreasing. So from here to here. So the wrong answer would be like net 8 and -1. That's how high and how low, right? That's not what I'm worried about. I'm saying from left to right. So we'd say from 0, I'm looking at my x-axis, from 0 to 3. And then constant, left to right. So from -infinity to 0. And then it asks us the number at which f has a relative minimum. So it occurs at 3. And then it says, okay, well, what is the relative minimum? What is the lowest it goes? And that's at -1. So again, being able to switch your eyes from looking at the y-axis to or from the x-axis to the y-axis. Then it asks us, okay, what would f of -2 be? So remember that in those parentheses, that's my x, right? So when x is -2, what is my output? What is my y? When x is -2, what is my y? 8. The values of x for which f of x equals 3. So they're saying, okay, what does x have to be when my output is 3? Well, when y is 3, I'm right here or right here. So I would be at 1 and 5. And then it asks about this function being even, odd, or neither. And in this case, it's going to be neither, but we're about to talk about why it would be neither.